Hi, today we're going to be talking about quadratic regressions. And if you recall, a regression is just an equation that models the given data. In the past, we did linear regressions, and today we're doing quadratic regressions, which is the same thing as a linear, except this one is a quadratic equation that best fits the given data, where before the linear regression was a linear equation that fit the linear data. So in example number 1, a toy rocket is shot upward from the ground level, and the table shows the height of the rocket at different times. So question A says, find the quadratic model for the set of data. So it's telling you that this is not following a linear pattern, it's following a quadratic pattern. So just like we did in the past, you're going to go to your stats or table, whichever calculator you use, and you're going to input your data. Okay, and then we're going to go back to our stat calculations, but we're not going to do linear regression. That's our line. We're going to do a quadratic regression. So you have to make sure they tell you that you use the appropriate regression. In the future, we'll also learn a couple more type of regressions, but you will be told which one to use, so make sure you use the one that they tell you to use. So just like before, you're going to hit it, and my calculator again looks different. For your X list, you'll have L1. For your Y list, L2. And your frequency list should be 1, or there should be blank. And then you're going to get your information out. So just like before, you're going to fill in the numbers into your variables. And always start off with Y equals. So you're going to fill your A number here, your B number here, and then your C number at the end. Okay, so the A number is -16. X squared follows that. Your B number is 272. X follows that. And then your C is 0. Although we can put +0, that's kind of awkward. So if it is a 0 value, that means that that term is not really there. So we can just take it off. So there is our equation that models the data. Now part B says, using your equation from part A, predict the height of the rocket at 1.5 seconds. So now it's all a matter of using your equation. If you recall, your first column is your X. So if we want to predict the height at 1.5 seconds, that's our time. And you can label the columns X and Y if that helps you. So that means that I have to replace the X values with 1.5. These are always the easier questions. Okay, so filling that in. We get 372 feet. And the reason why it's feet is because the units on the Y variable in the table were in feet. And I can also go to 1.5 seconds, which is right here. And 372 does make sense. Remember that the model is going to be around there, give or take. The model's going to go through some of the points or go above and below some of the points. But it makes sense. Okay, number 2, how many seconds after the rocket is launched will it take for the rocket to hit the ground? So how many seconds means that we do not know the time. So the X variable is what we're looking for, but we do know that we want it to hit the ground. And although they didn't say specifically what that is, you should realize that the hit the ground is what height, and this means the height is 0, or the Y is 0. So we're going to plug in a 0 for Y. When we're dealing with a quadratic and solving it, it's really nice to have the X squared be positive. So in order to get that to be positive, I could add it over, or I can just simply divide -1 by both sides. All right, now in order to solve this, I could try to factor it. I could use the quadratic formula, or I can even try to use the completing the square. So in order to see if it can factor, let's see if there's a GCF between 16 and 272. I'll try 16 first. Okay, 272 can be divided by 16. That means that there is a GCF of 16, and there's also an x in common. So setting both factors equal to 0. We already know that at time 0, that's when the rocket first launched, and that means that the other answer, 17 seconds, is when it's going to come back to the ground. Okay, trying this one more time. This time we have the price of a first-class stamp is shown in the given table. Part A, using x to be 0 for the year 1980. Find the quadratic regression that models this set of data. Well, that means if they want you to do this, they want you to change the year. And again, don't change the year unless they actually specifically tell you this. So they want 1980 be year 0. That means 1981 is 1 year later. 1983 is 3 years after 1980. 1988 is 8 years after 1980. And then you follow that. Oops, excuse me, 22. Okay, now I made a mistake. I apologize. I want you to round to the nearest thousandths. If they don't tell you to round, then you don't just make this up on your own. So I'm telling you I made a mistake. But in the future, if they don't tell you to round, you don't round. You keep all the digits. So going to our stat in our table, I'll clear out my list. Okay, so we have year 0, year 1, okay, we have 15, 18, 20. Okay, going back now to our calculations to get our quadratic regression, number 5. Okay, so all I have to do now is fill in my A number, my B number, and my C number. To nearest thousandths means 3 decimal places. So y equals negative 0.009, x squared follows that number, plus 1.143, x follows the B number, plus 16.189. And the last question, again, we always want an equation so we can use it, predict things. We want to know, predict the price of the first class stamp in 2015. Now, because we changed the years in the table, that means we cannot just put in 2015. We have to realize that this is the x variable because it's time, and we change the years in reference to 1980. So 2015 minus 1980 means that's, 35 years later. So that means x is 35. So all I have to do then is fill in the x value of 35. And then we will have our price. And remember, the units are going to be whatever the units were originally. So since the units on the y variable were in cents, that means my answer out will be in cents. So that means it's going to be approximately 45 cents for a stamp in 2015, which we're past it now, but remember, it's a model, so it's going to be approximately that price.